We've talked about exponential functions a little bit, but we haven't covered everything we wanted to cover in that short amount of time we had right before spring break. So the one thing that we didn't really get to was compound interest. Now it's not a big deal because you have a formula sheet, and the formula for the compound interest is on that formula sheet. So you don't have to do any hard work like that. All you have to do is be able to plug things into the formula and then maybe use the calculator to evaluate it. You certainly wouldn't have this on a non-calculator portion unless all it asks you to do is write the function, which we can do writing the function pretty easily. We don't have to use a calculator to work anything out. We just have to plug things in. Okay? But if it's on a calculator portion, then I assume they probably want you to work it out, after, like you'll see part B on some of these examples. All right, so the example, we have $9,400 deposited into an account at a rate of 6.3% interest, compounded semi-annually. So let's look at the formula first. Let's talk about what some of the key components are. So the formula is A. Oops, let me get the tool here. Okay, the formula is A of T, or I don't know how they typically write it. I don't know how it looks on the formula sheet, but A of T equals P. Now P's our principal, and that's going to be our starting amount. 1 plus R. R is going to be our rate, which will be the decimal value of our percentage value. N, which is our new variable, which references how many times it's compounded in a year, and then the exponent is n times t. So we have n in there twice, it'll be the same number both times, and t represents time in years. Alright, so let's set up a function for our example. Now remember, p is our starting amount, okay, and we're starting with $9,400. So if I'm writing a function a of t, now keep in mind it's not y equals, it's a of t equals. You have to pay attention to what the question's asking you to do, and you want to write it in this format. So we're writing a of t, and our variable that we're using is t, not x. All right, but our principal, $9,400, so 9400. All right, 1 plus r. Now our r value is our percent value, but remember we convert this to a decimal. So 6.3%, I know it is a decimal number. Every number has a decimal in it, but it's still a percentage value. And if we want to convert this to a numeric value, we have to move the decimal 2 places left, which puts it here, making it 0.063. So 0.063. Now our n value, which goes on the bottom of this fraction, n is based on how many times it's compounded. So this is semi-annually. Semi-annually means 2 times a year. So our n value is 2. So that's also going to be the exponent because our exponent is n times t. So it'll be 2 times t. Now it doesn't say what the year is. Remember, we're writing t in as x. So we're not plugging in anything for t yet because, as you can see, it doesn't tell us anything for years. We leave that as a variable. That's a function. Function has a variable in it like that. Okay. So back to the n value. So I wrote down on our notes that kind of how you determine it. So if it says compounded semi-annually, it means twice. Semi-annually means n is equal to 2. If it says quarterly, it means n is equal to 4. If it says monthly, I think this should be obvious. Monthly means 12. And then there's also just annually, which means just once a year, which you don't see typically too much. But these are key phrases so that you know what the n value is going to be. So since it said semi-annually, I knew it was twice a year, so I knew n would be 2. If it says quarterly, that's 4 times a year, so n would be 4. Monthly would be 12 times a year, etc. All right, so that's how you can come up with the n value. So see, it's pretty much as simple as just plugging things in. I think the hardest part is just converting your decimal values. But if you can handle that, I think you can handle pretty much this. All right. Now, if you actually want to evaluate this, it says part B is how much money will be in the account after 11 years. So that's when you plug in 11 for your variable up here. So let me write that first, and then I'll plug it in my calculator, okay? So we have our function a of t equals 9,400, 1 plus 0.063 over 2, and then it'll be 2 times 11. Okay, which you could probably just go ahead and write 22 if you wanted to. As personally, what I would do is I'd multiply this before I put it in the calculator, so I don't mess anything up on my calculator. Let's just go ahead and say that's 22, right? Because that's 2 times 11. So let me go pull up the calculator. Oh, hold on, I gotta close the screen out first. Apologize. Okay, pull up the calculator, and let's plug it in. So this is how you would do it. 9400, 1 plus. Now, I'm gonna put this fraction in its own set of parentheses. So the 0.063 divided by 2, you can see I put it in its own parentheses. Now I have to close the first set of parentheses, the one that I had before the 1. So you see there's 2 parentheses that open up and 2 parentheses that close, so I know we're all set. And then we'll do the exponent, which is n times t, which was, we said 22, right? And then we'll just hit enter and we'll evaluate. So just make sure you be careful with your parentheses. If you know how to type fractions in, it's probably better that way. But, you know, I don't, so I just kind of stick with it like this. So our final amount is $18,597.35 if you round up. Okay? All right. So all these are pretty much the exact same. All you're doing is plugging it in and finishing it off. So keep in mind for number 1, it says quarterly. I'll just help you out with that part. I think you guys can manage to plug in the formula. Quarterly means our n would equal 4. And 5.5% should be 0.055. Anyway, decimal should be here, making it a 0.055. Okay? You don't necessarily need this first here if you don't want to, but 0.055 would be right. Okay? So I'll let you guys work out the rest of those. Okay? For compound interest. Now, when it comes to growth and decay, this is stuff that we have covered. We should be a little bit familiar with these. All right. So the example. Bethany purchases a piece of heavy machinery for $12,200. The value of the machine depreciates at an annual rate of 4.9%. So also on your formula sheet is the exponential growth and decay formula. So you don't have to memorize those either. But just so you have them next to you, okay, you should have your reference sheet. And the functions or the formulas are y equals a, 1 plus r, and I don't know if it uses t or x, but I'm assuming it says t. And then the other one's the same thing, it's just 1 minus r. Okay, so obviously you got to be able to decide which one to use. Now this one says that the machine is depreciating. That would mean that we're going to use exponential decay. So we're going to use the one with the minus sign. So write a function to model this. So again, it's just plugging things in. A is our starting amount. R is our rate, again, typically given as a percent that we convert to a decimal, and then t is time in years. So let's write a function. Our function would be, by the way, it says the function is m of t, so make sure you use m of t rather than y, okay? M of t, and make sure you use the variable t. You have to write it as the question's asking, so pay close attention to that. All right, m of t equals now our starting amount, which is $12,200. And then it's 1 minus our rate, and our rate is 4.9%. But 4.9% would be 0.049. 0.049 to the t power. So there's your function, okay? However, and I'm going to erase my formulas. You guys have them, okay? But I'm going to get rid of them just because I need some space here. You'll probably want to write your function a little bit differently on the actual test. Although this is correct, I don't know because you have an idiot grading your paper. Sorry to call them idiots, but sometimes they are. They won't accept this. They might want you to simplify this part inside the parentheses, 1 minus 0.049. So if you want to get your calculator out, 1 minus 0.049 is equal to 0.951. Right? So they might want you to write the function with that instead. So meaning it would look like this. It would look like m of t equals 12,200 and then 0.951 to the t power. So you're basically just simplifying that a little bit inside the parentheses. I would write it like this just to be safe. I know in class and when you use a calculator you can use it like how I've written it, but testing people aren't that smart. So anyway, do it like that just to be safe. So we're going to use this equation. Didn't mean to erase all of it there, but we're going to use it to write, to work the rest of the problem out. So m of t equals 12,200, 0.951 to the t. Now it says in 3 years, so that means you're going to plug in 3 for the exponent. All right? So let's do that. It also says, in what year will the machine be worth $4,000? So what would be best is, since we have this calculator, going to our y equals and putting our function in there. So $12,200, oops, right, 0.951. And then to the t power, but of course our calculator uses x, same difference, it's the variable. Now, don't go to graph, you don't have to graph it, but go to second and then table, and it will show you all these values, including at year 3. So year 3, you can see it's worth $10,493. So you've got that. Now, but if it also asks, says part B, the answer to part B is sitting right here. Year 3, it's $10,493. But part C asks, what year does it go below $4,000? So scroll down until you see that amount go under $4,000. And we're getting closer. A little further. Year 23. Year 23 is the first year it goes below $4,000. So use that table. So again, what I did was I went to y equals. Okay, maybe write this down so you can do it again in the future. Go to your y equals, type in your function, make sure you plug in x as that exponent. All right, a lot of people go wrong because sometimes they type it in, either they type in a number for x, like sometimes, part B said 3, so sometimes they'll put in 3 here, and you don't want to do that, okay? And you also want to make sure that you use the exponent feature. If you just write, can I delete this as well? Yes. If you just write x here, then it's not to the x power, and it's gonna do it wrong. So you want to make sure you use the exponent button, that little arrow up, and then hit x. Okay. So make sure you don't make those silly little mistakes. Everything else is done for you. If you want to get to the table, you hit second and graph. It'll take you straight to the table. You have all the information you need right there. Okay. Now I think that's gonna be it for these. Because all the other ones are pretty much the same exact thing, okay? Just make sure you write your functions as I want you to write. So, for example, you can see in number 7, I want you to write h of t. So remember, don't use y equals, use h of t equals, and things like that. But go back to that table and use it for the rest of these, okay? See you later, guys. Bye.